Visualizing data is one of the most important tasks for data analysis, and one of the most used Python libraries for the task is Seaborn. In this video, I'm going to walk you through how to create visualizations using Seaborn and how to interpret those visualizations to tell a story like a data analyst. So let's get started. So the first thing you'll need to do is install Seaborn. To do that, you're going to run a pip install Seaborn command. Now, I already have this installed, so I'm not going to run it, but when you run it, you'll see it installing down here, and at the end, you should see a message that says Seaborn was installed successfully. Also, if you're wondering what setup I have locally installed Python, and I'm using VS Code as my code editor. I also have pip installed, which I use to download the different Python libraries. And if you want a tutorial on how I set it up, you can check out my video on that. So once we have Seaborn installed, we will do our necessary import statements. So first, we're going to import Seaborn as SNS. And SNS is the alias that we will use to refer to the different Seaborn functions. We're also going to import pandas so that we will be able to manipulate our dataset using a data frame. And we're also going to import Matplotlib. And that may be a little bit counterintuitive. You may say, well, we're learning how to use Seaborn. Why are we importing Matplotlib? And that is because Seaborn is actually built on top of Matplotlib. So Seaborn will create the visualization. It'll actually draw the lines and the bar charts and all of that. However, Matplotlib is going to be used to customize the figure that those visualizations are drawn on. So these are things like customizing the size of the visualization or customizing the title or axis labels of the visualization. Next, let's read in our data set and look at what the data is that we're visualizing. So I'm actually going to call this data frame coffee sales, and that is because we are going to visualize the sales data of a coffee shop. So the file that contains the data is called coffeesales.csv. This is a data set from Kaggle, and I'll leave a link to it in the description. So let's take a look at the first few rows. And you'll see we have different metrics about the amount spent on each transaction at a coffee shop. So we have the amount that was spent, it's called money. Then we have the hour of the day it was spent at. We have what the payment method was, the type of coffee that was bought. We also have this kind of grouped column, which shows if the coffee was bought in the morning, the afternoon, or the evening. Then we also have information about the day it was bought on, the month it was bought on, and the exact time it was bought. So when I see a data set like this, normally my first instinct is to kind of look at the distributions of the different numeric variables. Now here we really only have one really meaningful numeric variable, which is this money column, which is the amount spent on each transaction. So the first thing we'll do is we will look at the distribution of this column, and we'll do that using a histogram. So the first thing we're going to do is we're going to set the figure size for our histogram, and this is where we're going to use Matplotlib. So we're going to do plt.figure, and we will specify the figure parameter, and we'll set that equal to 8 by 5. Now we'll actually define the histogram, and we can do that using Seaborn's histplot function. Now histplot takes several parameters or arguments. The first is data, which specifies the data set that we want to visualize. So for us, it's going to be coffee sales, and that is the name of our data frame that we read in up here. It also takes an X parameter, which specifies what column of the data frame we want to visualize along the X-axis. Since we want to do a distribution of that money column, we will specify that X equals money. And we can also specify the number of bins for our histogram. This will be the different number of groups that we want for our histogram. So if we want payment amounts from like $10 to $20 and then $20 to $30 or things like that, we have to specify how many groups we want. Now we don't have a very large range for the amount spent in this data frame. So for now, I'm just going to set the number of bins equal to 10. Now, when we take a look at this, we can see here is our Seaborn histogram. And you can see we just have 10 different columns because we have 10 bins. And this is something that takes a little bit of trial and error. You can try out different numbers of bins to see which one works the best for your use case. Now this chart looks okay as is, but we can also add a little bit more information to it. So one parameter that Hisplot takes is called KDE. And what this will do is it will overlay a density curve on top of our histogram. And this will really just give us a smoother version of the distribution of the data. So we'll set that equal to true. And we can also change the color of these bars. So I'm going to set the color parameter equal to blue. In addition to that, we'll also make this visualization a lot more readable by giving it a title and giving it some better X and Y axis labels. And that is where Matplotlib comes back in. So we'll do plt.title. We'll set the title equal to distribution of amount paid, and we'll put a font size of 14 on that. And we'll also set an X label. We'll call it amount paid in dollars. And we'll also do a Y label, call that frequency, and then we'll do plt.show. All right, and now you see we have the title, we have the axis labels, and we also have that density curve overlaid on top of our histogram, which is now blue. So if we want to interpret this visualizations, we can see that we have a peak in our histogram around like $35 to maybe $37. So we can say a lot of our transactions are around $35. So now that we know about the distribution of the amounts paid, let's dive a little bit deeper into that. I think a really interesting question would be to ask if the spread of the amount paid or the median amount paid differs by the time of day. Remember, we have that time of day column that specifies if a transaction was made in the morning, afternoon, or the evening. So we can visualize the medians and the spread of the amount paid at each of those times using a box plot. So once again, we'll set our figure size, and this time to create the box plot, we're going to use the boxplot function from Seaborn. And this takes very similar parameters as the histogram. The first is going to be our data, which we will set again to coffee sales. It also takes the X, which is what we want to visualize along the X-axis, and we want the time of day column visualized along the X-axis. What we want is a box plot for each value of time of day. So we'll set this equal to time of day, and it also takes a Y parameter, which we will set to money because we are trying to visualize the spread and the median value for the amount spent, which in our data set is called money. So we can run this and we see we have our box plot. We have the spread of amounts spent by each value of time of day. Now we can make this visualization look a little bit better by changing the color of each of these box plots. We'll do this by using the hue and the palette parameters for the box plot function. So hue takes the column that we want to use to determine what color each box plot should be. And since we want the color to change by the value of time of day, we'll set this equal to time of day. And we can also set a palette parameter, and this specifies kind of what color scheme we want to use. And Seaborn has a lot of different predefined color palettes, and you can find which ones there are just by Googling Seaborn color palettes. But one I like is called Set 1, so that's the one we'll use here. And I'll also set the title X label and Y label. So here is that for this visualization. Here now we have a different color for each of the box plots for the different times of the day. We also have our title and our axis labels here. So to interpret this visualization, we can see that the middle line here, which represents the median, actually increases throughout the day, and it's the highest at night. Now this kind of raises a question as to why. Now I would expect that there's more spending at the coffee shop in the morning, since people probably drink coffee more in the morning, and I would have expected the median spent to be a little bit higher in the morning and then decreased throughout the day. Now there could be a couple of reasons why the median is higher in the evening. You know, there may just be more transactions happening in the evening, or maybe the number of transactions is the same, but the median is higher because maybe in each transaction people are buying a more expensive drink, which is driving the median higher. The good news is we can check both of these things using a bar chart. So first, let's make a bar chart to plot the number of transactions by the time of day. So the final chart will have 3 bars, and each bar will represent a sum of the transactions happening at that time of the day. So first, we're going to need to add a column to the data frame that indicates how many transactions one row represents. And in our data set, one row represents one transaction. So we will create a column called transaction count, and we'll set that equal to 1. So for every row in the data frame, transaction count will be equal to 1, since one row is one transaction. We'll also set our figure size, and now we'll create the bar plot using the bar plot function of Seaborn. Now this also takes the data parameter, which again will be coffee sales. It also takes X, which again is going to be time of day, just like it was for the box plot. And now this time Y is going to be equal to that transaction count column. And the bar plot function also takes an estimator parameter. The estimator parameter tells Seaborn how to group the data together by whatever we specified on the x-axis. So here we want to sum the transaction accounts by time of day. So we'll set estimator to sum. You can also set this to things like mean, median, length, things like that. And this also takes that palette parameter, and we'll set that equal to set1 like we did for the box plot. And let's also add our titles, X labels, and Y labels. And so now here is the chart, and you can actually see that it looks like there are the same number of transactions at each time of the day. It's not like nighttime or afternoon has significantly more transactions than the morning. So it's not that there's necessarily just more transactions in the evening. Maybe the drinks that are ordered are different. Maybe they're more expensive at night. So to break up the transaction counts by the type of drink that was ordered, we just need to add one more parameter to our bar plot, and that is going to be hue. And that is going to work exactly like it did in the box plot. Whatever column we specify here is how the bars will be broken up. So we're going to specify it to be coffee name. And since we will now have the bars broken up by their coffee name and each bar will have a different color, we also need to add a legend, which we can do using Matplotlib's legend function. So now when we run this, you'll see it is broken up by type of drink and by type of day. So here we have our bar chart, and you can see each bar is now representing a different drink type, and they're grouped by the time of day that they were ordered at. So if we look at the morning, we see that clearly Americanos are ordered the most. And you can see that bar kind of decreases in the afternoon and the night, but you'll see this red bar and this pink bar really increases. So those are lattes and cappuccinos. So that means that more lattes and cappuccinos are ordered in the night than they are in the morning. So I think Americanos are generally cheaper than lattes and cappuccinos. So it does make sense that the median transaction at night is a little bit higher than in the morning because people are buying more expensive drinks at night and cheaper drinks like Americanos in the morning. So I think that's a fairly interesting insight that people order more lattes and cappuccinos later in the day than earlier in the day. Next, let's look at if there's any trends on amount spent by the hour of the day. So to visualize that, we're going to use a line chart and show the total amount of sales by hour. So to do this, first we'll create a new data frame that actually groups the amount spent by the hour. So we'll create a new data frame called coffee sales by hour, and we'll set that equal to coffee sales dot group by. We'll group by the hour of day so that we get a sum of the amount spent at each hour of the day across all the days that we have the data for. We'll take our money column and we'll do a sum on that. And we'll also reset the index. So let's take a look at how that data frame looks. So here you can see each hour of the day and the sum of the amount of sales we have, or the total amount spent at that hour. Now we'll set our fig size, and we will use the line plot function from Seaborn. And once again, we'll specify our data set, but this time we're going to do coffee sales by hour. Our x-axis is going to be the hour of the day, And our y-axis is going to be that sum that we calculated up here. So this is our x and this is our y. And we can also set the color of the line. So we'll just set that equal to blue. And we'll also add in our title, x label, y label. And here you go. Here is our coffee sales by hour. So you can see we have the hours on the x-axis, the number of sales on the y-axis. We can also add a parameter called marker here. And we can set that to O. So you'll see what this does. It adds like dots at each point on the line chart as well. So that's another way you can kind of customize it. So now when we look at this chart, we can see that there is kind of a peak in sales at 10 a.m. Then there's a bit of a drop, and then there's another rise around 16. So I think that's like military time. So that's probably around like 4 p.m. So it looks like people are getting their morning coffee, and then they're getting kind of an afternoon like pick me up, maybe after work or something. They're stopping into the coffee shop. So I think this is kind of expected. You would expect the rush to kind of happen in the morning for a coffee shop. But as we found earlier, it looks like a lot of these people are buying Americanos, so the median spent is still a little bit lower than the median spent around here. But a lot of the sales are coming at 10 o'clock. Now we can also visualize this using a scatter plot. It's not the best use case for a scatter plot. Generally, I use those to see if there is a correlation between two continuous variables. Like if we had age and the amount spent, we could see if there's a correlation between amount spent by age. But for the purpose of this video and just showing you how to create a scatter plot, we can create one out of this. And it's actually going to be really similar to the line plot. We'll just switch out the function. We'll just switch out line plot for scatter plot, and the rest of this can actually stay the same. And you'll see we have our scatter plot. You can also even change the types of dots you have here. Instead of like circles, you could make them like plus icons, and you'll see each point is now a plus icon. For our final visualization, let's look at the total number of sales by the day of the week. And to visualize this, we are going to use a heat map. But to do that, we're going to have to rearrange our data set a little bit first. We're going to have to group it by the day of the week and calculate the total number of sales for that day of the week. So we'll create a new data frame called day totals. We'll set that equal to coffee sales dot group by. We're going to group it by the weekday column. That's our Monday, Tuesday, Wednesday, Thursday, Friday, and so on. And then we're also going to group it by the weekday sort column. Now this will help the data frame sort the weekdays in the correct order. So if you look at our data frame, you'll see that like Monday goes with number 1, Tuesday goes with number 2, and so on. Now here we're going to take that money column again, which is our sales amount. We're going to sum that, and then we're going to reset the index on it. And finally, we're going to sort the values by the weekday sort column. And we will take a look at day totals. So you'll see here we have our weekday, we have our sort order, and we have the total amount spent on that weekday across all the dates that we have in the data frame. Now we can't just pass this data frame to the heat map. Our heat map is a little bit different than our other charts in that it has to take a 2D array or list that contains the data that we want to visualize. So as a next step, let's reshape the data a little bit. We'll create a new variable called heatmap data, and that is going to contain a 2D list. We'll take our day totals data frame that we just defined. We'll extract the money column. So we're taking this column, and we're going to just extract the values from it. And I can show you that here. You'll see that we have just all of these values. Now we can't just pass this array because this is a one-dimensional array. It needs to be a 2D array. So what we'll do is we will use the reshape function, and we'll reshape it to have one row, and we're going to have it infer the number of columns it needs. So that's why we're using -1. Now when we run that, you'll see there's now 2 brackets. So this is now a list of lists, and we have one row, one list in this list. Now we can finally use this 2D array and create our heat map. As always, we'll set our figure size, and now we'll do sns.heatmap. And the first parameter, like always, is data. We will pass it our heat map data. Now this also takes another parameter called Cmap. And Cmap specifies what colors we want to use in the heat map. And I'm going to specify it to reds. So each square in the heat map will be a different shade of red. But I think there's also things like blues, there's like a red to blue, there's different values you can put for this. And kind of like the palette argument, you can Google the different Cmap values that Seaborn has. And we will set the X tick labels equals to our weekdays that we have in our data frame, in our day totals data frame. And we can also specify a Y tick labels. It defaults to like showing 0 there, and we don't want anything to show there, so we're going to make that an empty list. Now when we run this, you see we get our heat map right here. And we'll refine this slightly by just adding some titles. And I don't love how like square this is, so I'm gonna change this to like 10 by 2. All right, that's looking a lot better. So now here's our title, total spent by day of week. We have our X label here. And now here you can see that the color of each of these cells is determined by the number of sales we have. And it looks like on Tuesday, that's when we have the most number of sales. So it looks like the best day for our coffee shop in terms of sales is Tuesday. Now, if you want to see the exact number, you can actually add another parameter to the heat map. It's called annotation, and we'll set that to true. And it'll actually show these values on each of the squares. And we also want to format that, so there is a format function, and we'll set that to just show 1 decimal point. So there you go. Now we have the actual sales here, if you wanted to see that as well. All right, so we have a pretty decent story here with some interesting insights. We found that most of our transactions are around $35. We also found that our median transactions are higher in the evening than in the morning. And we also found that that was because we're selling more lattes and cappuccinos at night and more Americanos in the morning. However, as expected, we did find that our rush hour and our peaks in sales are occurring at 10 a.m. And we found that the best day for our coffee shop in terms of sales is generally on a Tuesday. That's when people are spending the most at our coffee shop. And we created all of these visualizations using Seaborn. If this video helped you understand how to use Seaborn better to create your visualizations and how to tell a story, I would really appreciate it if you liked the video. That lets me know that this video was helpful for you. Thank you so much for watching this video, and I hope to see you in the next one.